Alrighty, let's look at this linear first order ODE by the method of characteristics. This one's a bit more tedious than some of the other examples we've looked at, but it's kind of cool. Our first step is to parameterize our characteristics. Now, for whatever reason, I've let x be a function of y. We're given this initial condition, so obviously that initial condition becomes f of x naught. Once we've got these, once we live on the characteristics. So once we've got these characteristics, we can see what happens to u by the chain rule, right? We're interested in du dy, the total derivative of u. By the chain rule, that's the partial derivative plus this dx dy times du dx. Upon the characteristics, if this dx dy is equal to this thing, which defines our characteristics, then du dy is equal to x. Okay, by comparing this thing to our original PDE. So now we've got a bit of a wrinkle. X depends on x and y, the characteristics, and then u of y depends on x. We've got to solve for our characteristics first. Fortunately, characteristics only depend on one another. They don't depend on u, as they might in a quasi-linear equation. So we can solve this equation, which is a first-order linear ODE. We can solve that first. That's the canonical form of the first-order linear ODE, and we use the integrating factor method. So I denote my integrating factor with r. R integral of px, which is just -1. Integral with respect to y, the independent variable. So we have our integrating factor e to the minus yt. E to the minus y. Once we multiply through, we can collapse the left-hand side to this thing, and now we can integrate. Alas, we have an integration by parts. I know it's dodgy notation, but we'll just stick with it. This is u equal minus y, so du equals minus dy. V dv equals e. Oh, actually, I believe I did this in my previous calculation, so I'm going to stick with this for no particularly good reason. Okay, so let's plug into our integration by parts formula. U v minus v du minus the integral of v du Now, obviously, we want to rearrange just for x. So that involves cancelling as e to the y factor, or e to the minus y. Okay, now we have to apply the initial conditions. We know at y equals 0, x equals x naught, right? That's the way that we decide to impose these initial conditions. Thus, we can work out our constant of integration c. Now we also have a relation between x naught and x and y. So if you like, x naught defines a characteristic. So we want to figure out how that characteristic behaves. So this equation is important, but also the x naught in terms of x and y is important. So let's just rearrange for that now. I feel like there's a sign error. There is. I was supposed to divide by e to the minus y. That means that becomes a plus. When I divide that through, I should get e to the y. So this should be a plus and this should be a minus. Okay, and is there anything else I need to worry about? Move that there, plus 1. That thing there. All right. This equation, double asterisk, is also important, and we'll need to come back to that as well. However, we've now made progress. We now know x in terms of y. That means we can find u from this equation. So du dy equals x. So that's obviously du dy equals e, is y plus 1 plus, like so. Now we can crank through. We can integrate this. Some other constant of integration. We know that y equals 0, u equals f of x naught. That's our new initial condition. Plug in. Plus c. Oh, and that's 1, because e to the 0 is 1. Okay. So now that lets us write down a solution for u, at least along a characteristic defined by x naught. And now we want to substitute out those x naughts by our coordinates, or x naught in terms of x and y. So we use double star in this. Firstly, note, however, there's a common factor, right? So we can squish that into one term. I'm just going to briefly pause and check that I've got this right. Okay, I think I'm traveling okay. Let's substitute now this x naught quantity in here. So I'm just going to copy paste this so I have a reference down, and I can still read everything clearly. So double star into this. All right, so that's there in there. So that's that -1. It's obviously going to count that one. Okay, so something interesting is going to happen to this term here. Plus and so that cancels with that. I'm going to bring this e into here, right? Because this is just one term now. So we get x minus y minus 1 when we multiply this by e minus x minus y minus 1 e to the minus y. Right, so obviously this term simplifies out a little bit, plus this f term, which is still, there's nothing we can do about this one. We can write this term a little bit neater, as I said. By pulling this common factor out. All right, and we are done.